Hello and welcome to Arduino for Amateurs. This is episode number 21. We're going to talk about our Independence Day tree. As always, my name is Matt Gracie. I'm a hacker from Buffalo, New York. I'm a member of the Bidhaven Hackerspace. And what I'm going to be talking about today is programming WS2811 lights, specifically the lights that we have on our holiday tree in the Hackerspace. So first, I want to apologize. I know it's been a few weeks since I've published any new videos, and the reason for that is, in addition to my day job and my side job as a professor, one of the other things that I do is I'm the lead organizer for B-Sides Buffalo, our local B-Sides conference. We just had our 5th annual event last weekend on June 6th. It was a big success. Everybody had a great time, but as you might imagine, planning something like that is pretty time-consuming, so that's where my spare time has been going. Rather than continuing to play around with microcontrollers. So I apologize, but I'll make this episode a little extra long to try to make up for it. Now, this is our holiday tree at the Hackerspace. This tree topper at the top, the Super Mario Brothers power-up, we got that from Thingiverse, so if you want one of your own, just search for a tree topper on Thingiverse. You can print one out. This was originally a Christmas decoration, so I bought this little artificial tree. I put the lights on it, and I programmed them with a sound sensor and some buttons and some potentiometers to make sort of an interactive Christmas tree display. Once Christmas was over, I reflashed the Arduino that's controlling it with some code to do red and white chasing lights for Valentine's Day. As you can see here, we did white and green lights for St. Paddy's Day. And somebody asked me at the after party, after B-Sides, why don't you redo it for the 4th of July, for Independence Day? I said, you know what, that's a great idea, but I wanted to do something a little more interesting than just a static pattern. And since I don't have the tree here, I don't have the lights here in my office, I needed to find some other way to write the code and test it out. So that's what we're going to do tonight. Now, these are the lights that I'm using on the tree. I don't know if this company, if this brand name is still being used to sell these. This is from my order on Amazon. But just a few things that I want to draw your attention to. One, these are WS2811 lights, which means, as you can see here, these are individually addressable. Each light in the string has a little microchip, a little controller on it, as you can see here. That means each one of these lights, I can set the color, I can set the brightness, I can turn them on and off. I can do all of that programmatically and independently, right? I can change the whole string, or I can change just one light at a time. It's all controlled by whatever code I put into my Arduino. The other thing that I want to point out is these are the 5-volt driven lights, not the 12-volt driven lights. You can use the 12-volt lights if you want to, but you'll need an external power supply. You'll need some MOSFETs to cover the returning voltage. If you use the 5-volt lights, you can power them directly off of your Arduino, so it makes it a lot easier. Basically, we just string these all around the tree, and then as you can see, there's three wires here in the plug. We use some DuPont wires to connect these to the Arduino for power, ground, and a data line, which we'll also see momentarily. Now, I don't have these lights here. Again, they're on a tree at the Hackerspace, merrily blinking away. But what I do have is another WS2811 device, which is just this simple strip of LEDs. So you can't see them all in the picture, but there's 8 LEDs in the strip. You can kind of see them down here in the bottom right corner. I'll explain that in a moment. And then there are these 3 lines. So there's 5 volts, that's going to my power outlet here. There's a ground that's going back here to my ground pin on the Arduino. And then there's this data line. In this case, that's going to pin 6. You can set it to any digital pin you want to. I just used pin 6 because that's what I've used in the past. So this is going to be my tester for the code, right? Aside from the fact that there are only 8 LEDs in this strip instead of 50 like there are in the Christmas lights, it should behave the same way. So what I'm going to do is write the code and just use a variable for the number of LEDs. And then when I flash it onto the Arduino that's controlling the lights on the tree, I should just change that variable and everything should work normally. Okay. Now, let me flip over the code here. One other thing that I want to bring your attention to, you can see here in the bottom right corner of the screen, I've got an image, another camera here. There's my hand. I bought a document camera that's pointed at my desk right now, and that's that strip of LEDs that you saw in the photo. So as I change things in the code and as I flash the Arduino, you should be able to see the effects of that in that other camera view. All right. So there's the webcam that's pointing at me, and then below that is the document camera that's pointed at our LED strip. All right, so let's take a look at the code. We have at the beginning here an include for fastled.h. Fastled is the programming language, or is the programming library that we're using to interface with these WS2811 LEDs. So what that does is it gives us the appropriate syntax and objects to programmatically address these LEDs, and that's what we're going to do. And then we have some definitions here. We're going to define our LED pin. That's pin number 6. Again, as you saw earlier, that's where I have this strip plugged in. We're defining the number of LEDs. That's the number of lights in my strip. We've got 8. We're defining the default brightness. We're defining the fade delay, which I don't think we actually use in this code. I just copied that over. We're defining the LED type. The LED type is WS2811, and we're defining the color order. That is, how do we send color data to the strip as RGB. Now, the way these strips work, or at least the way I'm working with them, is that you generate an array with the number of LEDs in it of type CRGB. CRGB is the RGB color value for each LED. So, so what we see here, we have CRGB LEDs, that's the name of our array. The array is number of LEDs in length. So we have an 8-item array, because number of LEDs is 8, named LEDs, and what it contains is data of type CRGB. We also have another variable called temp value, of type CRGB. We're going to use temp value when we start moving stuff around on the strip, and you'll see that when we start getting into the code. These 2 integers we'll skip for now. We'll need those more in a moment. For now, I think what we want to do is we want to just make sure that our LEDs work, okay? So in our setup code, first thing we're going to do is delay by 3 seconds, 3,000 milliseconds. What that will do is it will give us a little bit of a delay between the time the Arduino comes up and starts powering the strip and the time we start pushing data into it. We're going to use this fastled.addLEDs method, right, to add this this controller, and then this syntax, the LED type, the LED pin, the color order is all the stuff that we defined up here. We're going to set the brightness for all our LEDs to brightness. And then this is the meat of it. We have a for loop here because for loops and arrays go together like peanut butter and jelly. It's the best way to do it. And we're going to say for int I equals 0. So we have a counter integer that starts at 0. I is less than num LEDs, so I will count up. That's the I++. 0, 1, 2, 3, 4, 5, 6, 7. All right. So we're going to go from 0 to 7 because we have 8 LEDs, and like all good computer scientists, we start counting at 0. And in each of those boxes in the array, in each of those positions, LEDs I, so LEDs 0, LEDs 1, LEDs 2, etc., we're going to set that to 255, 255, 255. So that's maximum red, maximum green, maximum blue. What does that give us? That gives us white, right? So we're going to put this value into every box in that LED array. And then we run fastled.show. And what this does is it takes the values that are in that LEDs array and it flushes them out to the LEDs themselves and turns them on. So it's a 2-step process. First, we set the CRGB value in the array, and then we use show to push that value to the strip and light up the LED, right? And then our loop here, we've got nothing. So we'll come back to this. I wrote some routines that we'll talk about in a minute. But for now, we just want to make sure that our LEDs work. So I will check this. I'll run verify just to make sure I don't have any syntax errors in here. Okay, everything looks good. Now when I push this out, you should see in the bottom right corner, all 8 of those LEDs light up. There we go. 8 LEDs. 1, 2, 3, 4, 5, 6, 7, 8. All lit up, right? If I want to change the color, so for example, if I want to turn them all red instead, I just need to do that. I'll upload it again. All right, done uploading. And, oh, it turned them all green instead of red. So apparently we're using green, red, blue encoding. Let's confirm that. That's interesting. So I would expect this to be green, but given what we just saw, maybe it will be red. And there it is. It's red. So it looks like red and green are flipped. Okay. We'll have to keep that in mind going forward. So RGB works for my Christmas lights, but apparently it doesn't work for this particular little strip that I'm testing with. No problem. All right. So there's a couple things that we want to do here. My ultimate goal is I want to gradually fill my LEDs with red, white, and blue, for Independence Day, then rotate them forward, then rotate them backward, and then from the end to the beginning, erase one LED at a time, right? So it's a little bit more interesting of a display than just chasing lights. So the first thing we need to do is figure out how to rotate forward. So what we're going to do is we will update our setup here and add this if statement. So what's going to happen is we're going to delay. We're going to add LEDs to the fast LEDs. We're going to set the brightness. We're going to do that same for loop, but this time we're only going to light up one of the LEDs. We're going to light the first one to white. So if I equals 0, we're going to set LEDs I, LED 0, to white, 255, 255, 255. The rest of them we're going to set to 0, 0, 0. That is no lights at all. All right. So what we want to do is we want to turn on just the first LED. So let's do that. All right, flashing. And there we go. We've got just one LED lit up, right? The other 7 are all empty. Just one is lit up in white. Now, what we want to do is take that white LED and rotate it from position 1 to position 2 to position 3 to position 4, right? Because we're doing it kind of like a cursor. We're going to go 1, 2, 3, 4, and rotate forward. So our routine for that is called rotate forwards, and we'll jump down to that code in a minute. I'm just going to uncomment this to turn it on. So what this is going to do is it's going to create a new counting variable called counter. Counter is set equal to 0. Counter will go up by 1 until, and the counter is less than a number of LEDs, right? So what this should do is it should just rotate forward until it gets to the end of the string, right? It should go 0, 1, 2, 3, 4, 5, 6, 7, and then stop, and then maybe start rotating forward again. I'm not sure. We'll see what happens. What does rotate forwards look like? Well, what we're going to do is we're going to take that temp value, right? And the temp value, we talked about that. That's the CRGB variable that was up at the top there. We're going to set temp value to the value of LED num LEDs minus 1. Okay? So what are we doing? We are taking the very last value in the array. So if we have 8 values in the array, we're taking the value that's in box number 8 and we're copying it into temp value. We're not changing it in the array itself. We're just making a backup copy of it because we need to preserve that value. Okay? And then the next thing we're going to do is we're going to stop at that box, that num LEDs minus 1, so box number 8 or index number 7. and we're going to change the value of index number 7 to the value of index number 6. Okay? So we're moving the value of 6 over to 7. We're going to move the value of 5 over to 6. We're going to move the value of 4 over to 5, etc. We're going to step all the way through because we're using this minus minus decrementer here. So we're going to start with 7 and set that to the value of 6. Then I gets decremented. We go to 6, we set it to the value of 5. We go to 5, we set it to the value of 4. We go to 4, we set it to the value of 3, and so on. Until we get to I is 0. And then we stop. Okay? And then finally, you know what, we probably don't even need the equals there, we just need a greater than. And then at the end, we said 0 equal to temp value. Now, what was temp value? Temp value was originally the value of box 7, right? The 8th LED. So we're moving everything up by 1 and then putting that last value back at the beginning, okay? And then we do a show. So what this should do is it should do this rotate forwards 8 times. And then we'll tell it to delay for 5,000 seconds. And then it'll start over again. Okay, because this is the loop. It's going to just keep doing the loop thing. Let's make sure we don't have any syntax issues here. No syntax problems. So we'll hit upload. All right, and what you should see in the bottom right corner there is that white LED bumping forward. It goes all the way to the end. Skips around to the beginning because, again, we're doing it the number of LEDs times, so it goes forward 8 times. And then pauses for 10 seconds and then rotates again. Right? So we're just rotating through that one variable, that one LED value. Now, one thing that you'll notice here in this rotate forwards is that we're not changing any CRGB values directly, right? All we're doing is copying the values that are already there into the adjoining spot in the array and then showing the LED again. So all of the explicit creation happens here. So if we want to do this with red instead of white, we could change this. It'll reset our strip. It'll change that light from white to red. And then we'll see the red light is rotating instead, right? So we've got kind of 2 sections of this code that we're working with. Setup writes all of our values in, and then rotate forward just rotates it forward, as the name implies. All right, so that's one thing that I want to do, right? I want to be able to rotate forward. Another thing that I want to be able to do is rotate backwards. So let me uncomment this. All right. And then if we go down here to rotate backwards, you'll see it's pretty much the same thing in reverse. Instead of taking the last value in the array, we take the first value in the array, we stick it in temp value. Then starting at 0 and working through the array, we change the value of each box to the following box. So 0 becomes 1, 1 becomes 2, 2 becomes 3, 3 becomes 4, etc. And then when we get to the end, we set that to temp value. So rather than copying the values forward, we're copying them backwards, hence rotate backwards. And then we do an LED show. So if I go back here, and now that I've got rotate backwards enabled, we hit upload. All right, it'll reset to the beginning of the string. Rotate forward, 1, 2, 3, 4, 5, 6, 7, and then it should rotate backward. 1, 2, 3, 4, 5, 6, right? So it goes in one direction and then the other. Again, we're not doing that initial creation item. We're just moving the values in the array. And as we move the values in the array, we use that fast LED show to flush them to the strip and reflect them on the LED strip. Okay? So very simple. Rotate forwards, we rotate backwards. Now there's two more pieces that we want here. One is to fill the string. So this is a little bit more complicated, so stick with me. But what fill string is going to do is it's going to give us those red, white, and blue sort of double clusters all the way down the string. So we're going to start with current position, which is just a counter variable, right? We originally instantiated that up here at the top. We set it equal to 0. So we have current position and loop counter are both 0 initially. So while current position is less than number of LEDs, so in this case it's going to count from 0 to 7, we have a counter variable called LED counter. LED counter is less than current position. LED counter is plus plus. And then what happens is we slowly fill the string, and we are using a modulus operator here to tell it what color to use. So if LED counter modulus 6 is 0 or 1, then we're going to turn it red. If it's 2 or 3, then we're going to turn it white. Otherwise, we're going to turn it blue. So practically, this means there will be 6 LEDs in a row. The first 2 will be red, the next 2 will be white, the next ones will be blue, and so on. And then current position will be set to white. So what this is going to do is it's going to slowly fill up our strip with red, white, blue, delaying by 2,000 in between, right? So delaying by 2 seconds. So if we set this, let's go here and uncomment our fill string, right? Upload. Right. So you can see the white is moving along almost like a cursor, and then it's leaving behind red, and then white, and then blue, and then it'll do red again, right? So it fills up the whole string, and then it does the rotate forward. So all of the colors rotate forward and loop around. When it's done with that, it'll enter rotate backwards. It'll start going in the other direction, right? So we're just doing this on a small string here, but all we need to do is change the number of LEDs variable. We'll be able to do this on that whole line, that whole string of Christmas lights on the tree, which can be pretty sweet. Now the last thing that we want to do is right here, we have one last function we called empty string. An empty string is fill string in reverse, right? So what we're going to do is we're going to stop, we're going to set current position, right? So current position, when it comes out of fill string, current position is set to 1 less than the number of LEDs, so it should be set to 7. When we get to empty string, it will set LED counter to current position. LED counter is greater than or equal to 0, LED counter minus minus, and it will go through and set those to 0, 0, 0, that is, turn off the LED, and then show, and eventually set current position to 0. So our current position variable is tracking sort of where we are in the pattern, and what this will do is it will slowly turn off the LEDs from the end of the string to the beginning. So we have uncommented that. Let's upload. right, our sketch is compiled. It is uploaded. You can see on the screen over here, it is filling up the string, red, blue, white, blue, right, continuing, and then it will tick through. It'll rotate forward 8 times, pause for a few seconds, rotate backward 8 times, and then it should do our empty string routine. Okay, now it's rotating backwards. And now it should empty. Say they're turning off one by one. So this will do the same thing on that larger tree. It will start at the bottom of the tree. It'll do red, white, and blue all the way up to the top. Then it'll rotate forward. There's 50 lights on the tree, so it'll rotate forward 50 times. Then it'll rotate backward 50 times. Then it will gradually turn the lights off from the top of the tree down to the bottom, and then loop around again. All right. So again, a little bit more interesting than just plain red and white or green and white chasing lights. I was able to test it here because I have this little strip of WS2811 LEDs that I was able to test my code and make sure everything works. What I'm going to do is I'm going to save this. Then I should be over at the Hackerspace tomorrow. I'll take a video. I'll make sure everything works, and then I will post it as a companion to this one. All right. Thank you so much. I hope you found this interesting. Again, sorry it's been a little while, but I hope it was worth the wait. Take care.